Alright guys, so we're going to move on to Narnia 1 now. Pretty sure this level gets a little bit more challenging. Uh-oh. I messed up. I think I forgot to put the password in this file. Yeah. Alright. Okay, so we're in Narnia 1 now, so let's take a look at the program. Okay, so this one, it looks like what it's doing is it's literally going to treat an environment variable as a function. So you're never gonna see anything like this in the real world, but this is just to kind of teach you that you don't have to compile your code to execute it. You can kind of inject it into the program, and it as long as it has the instructions in memory, it really doesn't matter where it's at. For the most part, of course, there are parts of the process that will tell you can't execute, but it's not important for this level. So basically what we got to do is just put some code in egg, and what we want to do with the code is have it execute a shell, because if you remember, this program is running as Narnia 2 here with this S flag. So if we get it to execute a shell, we got a shell as Narnia 2 and read the password. So this is where we're going to get the concept of a shell code. And I already have one ready. These are pretty easy to find online. Just kind of go to Google's, type in the shellcode database. This one is the one I've been using because it's nice and small. It's only 23 bytes. Basically, what it does is it's just the bare minimum that you need to make a system call to this exec v, and then it's just gonna do this. Basically, it's going to tell Linux, like, hey, we want to start a new process, and we want to use this program for the code. Maybe I'll show you what I mean. But so basically, what I can do now is I can set this environment variable egg to this code. So this thing right here is just gonna saying like run this command, take the output of it and place it here. Okay, so get my everything matching. So now if we like echo egg, this is the ASCII representation of this code here. Okay. So now what we're gonna do, I'll pull this up in GDB first just to show you what's really going on here. Okay. Let's take a look at the main function. So what we're doing here, right here, is where it's calling the address stored in EAX here, and the EAX came from this getenv call. So that's, you saw that in the source code. So if I put a breakpoint here, right, and I run it, okay, so it says it's trying to execute egg, and so we have this memory address here. I'm pretty sure this is the address for where like the data for egg is stored. Like, and we can kind of look at that. Yeah. So what I'm doing is this X is for, it's called examine. So that lets you look at the memory of the process as it's running. And then as I said, this is 23 bytes long. So I've got 23, X is for hexadecimal, and then B is for like 1 byte at a time at this address. So These are all. This is the code. These are the machine instructions itself, and this is. You can see this and this are the same thing. So I've actually managed to inject this into my running program, and it's about to run a call on this address here, right? So if we take a look at if we use the I instead of the X, it's going to interpret these as instructions instead of just the raw bytes. So if we look at that. Okay, this is the shell code. This is the code that spawns a shell for you. So basically, I can kind of explain how this works, but it doesn't really matter for. This is the string /bin/shell, and then these are other arguments to the system call. OXB, that's the Linux code for execve here, and then when you do interrupt 80, that's gonna tell Linux like, okay, hey, look at my stack. I'm requesting a system call. I have these arguments on my stack here, so I want you to do this for me. So when I do continue, it says, ooh, it didn't work. All right. Says OXFFFFDF24 in. All right, let's see what's let me try this again. So something went wrong. I'm gonna restart my program. Let me see if it actually gets to this address here. I think it should. Yeah, all right, we're here. So we can, this EIP here is our special register, and this is pointing to the next instruction that the processor is going to execute, whatever EAP is. So EAP is set to our code here. You can see it's about to execute like our next, so I'm pretty sure we're going to get to here, and then break here, continue to there. Okay, so it looks like we're about to call our interrupt. Alright, if I type next slide, that's weird. It looks like it just skipped over it, and this might be just a quirk with GDB where it's not executing. Let me just try that in the real world. That's okay. That's interesting. Yeah, here we go. It's trying to do the. Oh, I'm getting an error for an exec VE call. That's interesting. Okay. Let's take a look at that. So, this is a great skill to have, is knowing how to Google stuff. Let's see. Default. Path name, and what are the pointers in the vectors argv or mvp points outside your accessible address? Wait, okay. We're not passing any arguments, so these should all be empty. We just have the path name here. And so okay, let's see what's going on. Let's put our breakpoint in again. We're gonna take a look at the stack before it makes the call. Okay, and so I think there should be forget exactly how this works. Let's just look at 5 words. This W, by the way, is 4 bytes at a time, and it's the little endian mode, so like you can see, like, in reality, the A4, the D6, the FF, the FF, they're stored like that, but when it's looking at it as a 4-byte unit, it treats it, it knows like it's in little endian mode, so the FF actually goes to the most significant, it's the most significant byte in this word, in this 4-byte number here. Okay, so we got OX, FF, FF, D6, A4. I think that's our shell. And this is a 0. Yeah, this is just, this is like the address for this here, which is the string itself. And then this 0 here is, really not sure what's going on. I guess maybe something is wrong with the shellcode. I could try to debug it, but I'm just gonna really quickly try a different shellcode instead. So it's 86 Linux shellcode data. Just kind of see what's going on here. Let's obfuscate. That's I can't make sense of that, but whatever. So let's copy this. Maybe this will work instead. You never know. That's not what hang on, let me format this real quick. C1, C9, F7, E9. Yeah, okay. A lot of times it's just quicker to type something out again than backspace through it all. Alright. Okay, let's try that. Maybe that'll work, you know? Okay. It didn't like something about this. I could go through like the machine instructions and try to debug, but when it comes to this, it's, there's nothing wrong with knowing what resources you have, like such as these databases, and just kind of trying a few different things, so you don't have to waste a bunch of time, going through. As long as you understand the general concept of what this is trying to do, you don't need to become like an assembly code expert, or especially at on this stage. All right, so let's get the password. All right, there we go. Took a little longer than I thought, but not a big deal. I'd do we can get in. All right, there we go. All right, see you guys next time. Thanks.